Today, we are going to continue about Sanjay Sky Park's construction. First, let's talk briefly about the contents of the last presentation. To overcome the steep inclination of the building's lower part, they used the vertical post tension method. Along with this first tried technique, temporary bracing was used as the building rose. To reduce the possibility of failure more surely. And transfer trusses were installed on the 23rd floor. They transfer the load of superstructure from tilted structure to the vertical structure, reducing the load transferred to the tilted structure permanently. After this, the building could go up safely up to 55th floor. Finally, we were able to complete these 3 slanted buildings safely. And we moved on to the next page, last presentation, the Sanjay Sky Park. It's covering more than 10,000 square meters and weighing more than 60,000 tons. It's 340 meters long and 40 meters wide. It was very huge and giant structure. How big is the Sanjay Sky Park? 4.5 units of the Airbus A380 jumbo jet can be arranged. If you don't get the hang of it, think of the 300-meter long Eiffel Tower. Imagine that the Eiffel Tower is laid at the top of 3 55-story buildings tilted up to 52 degrees. It will be understood at once how ridiculous this sky park structure is. This huge Sanjay Sky Park is divided into 5 distinct sections by 4 movement joints. They can accommodate differential movements arising from thermal expansion, wind-induced movements, and time-dependent movements such as creep or shrinkage. 3 of them are sections connected to hotel buildings directly: Tower 3, Tower 2, and Tower 1. And remaining 2 sections are the bridge sections that connect between buildings in the air. Also, Tower 3 section has a massive cantilevered deck. We introduced last time that there were 2 main ways in which the tower sections were supported. They were W-shaped columns and central lift cores. So, look at the load path of tower sections. It could be delivered to the building and safely to the foundation. So, how do these bridge sections, which seem to be floating in the air, carry loads without falling? The answer was 3 giant steel trusses. The frame of bridge sections consists of these 3 trusses, which were incredibly large and heavy structures of over 350 tons and over 50 meters. On the trusses, cross-girder beams are placed at intervals of 4 meters, and composite slabs are placed on them to transfer the load to the truss. So the vertical load is transmitted from side to side through the trusses. The transmitted load is safely transferred to the foundation along with something called shear walls. Then today, let's talk about this cantilever structure in detail. How can this zone, which apparently does not have any support, be kept safely? Let's get a closer look. This, this is the longest cantilever deck in the world. It is 67 meters long and 200 meters above the ground. The weight of this massive structure is 3,500 tons, pulled down by the gravity. Then, doesn't it make sense to collapse like this? Why doesn't this structure collapse and fall down? The answer is the steel box girder. The east box girder is 76 meters long, of 786 tons, and the west box girder is 74 meters long, of 746 tons. It's a huge steel frame structure. This box girder is a secret of the cantilever section safety. The load of the cantilever is transferred to the building along the box girders. So, what is the box girder? A box girder is a girder that forms an enclosed tube with multiple walls, as opposed to an I or H beam. It better resists torsion compared to an I beam. It can carry more load than an I beam of equal height with multiple vertical webs. So the box girder is usually used for bridge construction. As such, many bridge construction technologies were incorporated to build Sanji Sky Park. This picture shows the rear main box girders. Two main box girders were placed east and west, and after they were placed, 6 box girder segments are connected with them to support cantilever. In more detail, the main frame of Sky Park is as follows. 6 box girders form the frame of a cantilever. 2 main box girders connect cantilever with hotel tower on Tower 3 section, and 3 trusses from each bridge section. As such, the main frame of the Sky Park is divided into 14 segments. Also, the main box girders are supported by 9 columns connected to Tower 3. Let's talk more about the main box girder. These pictures shows elevation and plan of Tower 3 section with cantilevered structure. As you can see, the cantilever frame comprises a pair of variable depth box girders. General depth is 3.55 meters and the maximum depth is 10 meters. And it is 4 meters wide. The west box girder weighs 746 tons and 74 meters long. The east one 786 tons and 76 meters long. Then columns are embedded atop of the hotel tower to support the main box girders. It is the primary structural system for the cantilever section. This is a drawing of the box girder. A number of framing options were considered for the Sky Park early in the design process. All pre-schemes were assessed for both their weight and ease of construction. Finally, the post-tension steel box girders were selected. 4 meters wide and 10 meters deep. After the main box girders were installed, 6 cantilever segments were connected. In order from left to side, segment 1 to segment 6. Weight and lengths are as shown in the following table. The average weight and length are 140 tons and 8 meters long. Transverse girders are installed vertically and have a depth of 1.25 meter to 1.75 meter and placed about 4 meter apart. On top of them, composite deck slabs were placed with a thickness of 175 mm to 225 mm. How many people can this completed cantilever accommodate? The maximum capacity of observation deck is 600 people. An outdoor restaurant terraces is 470 people, and indoor restaurants is 345. And the maximum capacity of Hull Sky Park is 3,900 people at one time. In order to accommodate so many people, human-induced vibrations had to be carefully considered. The design predictions for the Sky Park's dynamic performance were based on various assumptions. To confirm the performance of the completed cantilever, a program of dynamic tests was carried out on 24 to 27 May 2010. This included vibration response measurements of individuals and groups walking, jumping, and dancing. This is the graph measured in the Lear test. As the crowd started to move, the amplitude started to increase. And when jumping, the amplitude increased by a large margin. After the activity stopped, it slowly began to decrease. To minimize vibrations caused by people's activities, a tuned mass damper, called TMD, was installed at top end of the cantilevered deck. The TMD, which is custom-made through pre-data of target structure, reduces the vertical vibrations of the cantilevered part. Tuned mass is 5 tons and frequency is about 1 Hz. This is a cross-sectional view of TMD used in Sky Park. There's a base plate for fixation. At the top, there's a required steel mass, and at the middle of them, steel springs with frequency are located. At first, the plan was to install 4 15-ton TMDs, but the plan was changed to install only one 5-ton TMD, considering weight and dynamic test results. The vibration graph recorded in the jumping test shows that the amplitude when TMD is installed is much smaller than when it is not installed. We studied the support of distinct 5 sections and load distribution together. Today, we discussed about why cantilever structure was not collapsed. Then, how did that massive and heavy structure get lifted and positioned? Let's look at the 14 main frames again. All segments are over 100 tons and some of them even over 700 tons. Cranes used at general construction sites can lift up to 20 tons. How could these heavy steel frames be lifted up to 55 story? We will handle with this question next week. See you next presentation. Thanks.